Hi, Pre-Calc. I just decided that I would walk you through the Aleks 1.7 just in case you have questions, and you could go ahead and fast forward to the problem that you would like help with. And I thought maybe this might be helpful. So I'm going to just start from the beginning and start working my way. So this question number 1, W of U of 3 is what they're asking us to calculate. So if I was going to calculate U of 3 over here to the side, negative 2 times 3 minus 2 is negative 6 minus 2 is negative 8. So this is actually W of negative 8. So now when I go to the W, I put negative 8 in. And this is 2 times 64 plus 2. So this would be 128 plus 2, giving you an answer of 130. Okay, so all I did was calculate the U of 3 and then put that in and calculate the answer, W of that answer. For question number 2, suppose that the functions f and g are defined as follows. This is the one that I did in class, but I can try and do another one. I don't know if you needed it, but f of x, remember that you are putting the f function, the entire function, where there is an x in the f function. So this becomes 5 over 1 divided by, that thick line is your divided by, right? And then 5 over x, which we know for division of fractions, you multiply by the reciprocal. And the 5's cancel, so you get x for f for this first one. And then the g composition g of x, you're going to put that whole function in, x squared minus 4, into where the x is in the function. So this becomes x squared times x squared is x to the 4th. You've got a negative 4x squared and another negative 4x squared, giving you a negative 8x squared, and negative 4 times negative 4 is positive 16. Bring down that minus 4. So this becomes x to the 4th minus 8x squared plus 12. And that would be your answer for g composition g. Number 3, for the real valued functions, find the composition g composition h and specify its domain. So you're putting the h in where the x's are in the g function. So we've got our 4 times, and that's where we're putting our h in. The square root of x minus 3. We're putting it into where the x is in the g function. And so we end up with 4 times the square root of x minus 3 plus 5. That would be your g composition h. And to find your domain, remember that the domain for h, this has to be greater than or equal to 0. Sorry, I put equals, but it should have been greater than or equal to. And then add 3 to both sides. X has to be greater than or equal to 3. So your domain is going to be from 3 to infinity. So that is your domain for that composition function. Okay, the next one, question 4. The area A of R in square meters of a circular algae colony with radius r meters is given by A of R equals pi r squared. The radius m of t in meters after t minutes is given by m of t equals 4/3 t. Write a formula for the area z of t in square meters of the algae colony after t minutes. It is not necessary to simplify. Okay, so your z of t, which is basically you're putting, because they're saying that the radius here is m of t. So this right here is r. So you're going to put that in for r up here. So this is going to be pi times 14/3 t squared, because we just put that in for r. And they said we need not simplify, but if I was doing this problem, I'd probably take 14 and square it. I get 196, so this is going to be 196 t squared over, and then I would take the 3 and square it, 9, and then pi. Or, I mean, of course, the pi might go with the, I was just seeing if 196 over 9 reduced, but it doesn't. The pi might go with the the 196 over 9 and then do the t squared. Okay? However you want to write it. They acted like not necessary to simplify. I think you probably could have written that and been fine. Okay, on to question 5. For the functions f of x equals x over x minus 1 and g of x equals 13 divided by x, find the composition f, composition g, and simplify your answer as much as possible. Write the domain using interval notation. So I'm taking the g and putting it into the x and f. So notice that there are 2 places where we have an x in f. So I'm going to have to put this entire function in both of those spots. And so I'm going to say that this is equivalent to 13 over x divided by 13 over x minus 1. And so what I probably would do is multiply this 1 over 1 by x over x to get a common denominator, because I want it to be a fraction divided by one fraction. And if this was, 1 divided by 1, and I said, okay, well, I want it to have the same denominator, I would multiply by x over x, giving me 13 minus x all over x. I would then put my numerators over one denominator. Then I would be able to multiply by the reciprocal of the denominator over itself, right? Because you're multiplying by a fraction that equals 1, but look, it gets rid of this denominator down here, and it gives you a simplified form. Those x's cancel, and you're left with 13 in the numerator, right? Because 13 times 1, numerator times numerator, so that's 13. Denominator times denominator. So this is your 13 divided by 13 minus x is your f composition g of x. What would your domain be? Well, you got to be careful because it's created by a function that you cannot put 0 in. But then when you get done, though, when you've simplified it, you can't put 13 in it. Okay? So when I go down here, I'm just going to check my answers. We have to take out, look here, here's the answers. We have to take out 0 and 13. Okay? So I just wanted to make sure that I was telling you correctly. So negative infinity to 0, union 0 to 13, union 13 to infinity. That's going to be your domain for this. And again, it was created by this. So this actually, x couldn't be 0. But then when you simplified it, you saw that x can't be 13. Okay? Because if this would have been if x would have been 13 right there, 13 divided by 13 minus 1, well, that's 1 minus 1. So these are both problematic for this. So you had to take those out, okay? All right, the next one, for the real valued function g of x equals x minus 4 over x minus 3, and h of x equals 2x plus 7, find the composition g, composition h, and specify its domain using interval notation. So I'm taking the h function, putting it into the x in the g function, but there's 2 places where we have x's in the g function. So I have to put the entire h in both of those spots. So I'm going to say that this function is equivalent to 2x plus 7 minus 4. Look, I put the whole h function into the x in the g. 2x plus 7 minus 3. Now I'm going to simplify. 2x plus 3, because positive 7 minus 4 is positive 3. 2x plus 4. So positive 7 minus 3 is positive 4. So this is my function. 2x plus 3 over 2x plus 4. Now, what about the domain? Well, for this one, like this original one is going to, it simplifies and it's going to give you the same 0 no matter what, right? If I set that equal to 0 to see what gave me 0, or I set that equal to 0 to see what gave me 0, both of them are going to be the same. So 2x equals negative 4, x equals negative 2. So that is what I have to take out. Negative infinity to negative 2, union negative 2 to infinity. Okay. So now, question 7. Suppose that the functions f and g are defined as follows. And find f divided by g and give its domain using interval notation or union of intervals. And so this is going to be the x divided by x minus 7 divided by x plus 5 divided by x minus 7. So this is one of those fraction divided by a fraction. I can multiply by the reciprocal of the denominator over itself. You want to make sure that this is a fraction that equals 1. You want to make sure that you get rid of everything down here in the denominator. But look what happens. These x minus 7s are going to cancel, and you're left with x over x plus 5. So your new function, your f divided by g of x, is x over x plus 5. But since it was created by, taking, 1 divided by the other, x cannot be 7, because look, if x were 7, it would cause problems here. So x cannot be 7. It also cannot be negative 5. So your domain is negative infinity to, negative 5, union negative 5 to 7, union 7 to infinity. I want to check that one too, just to see if we got the same answer. Look, they took out negative 5 and they took out 7. So yes, we did get the same answer there. Okay? All right, now we go back up here. I'm almost to the one that I wanted to show you, which is the main reason why I made this. Question 8, suppose that the functions f and g are defined as follows, and then find f plus g and f times g and give their domains. So f plus g is just going to be 1 over 5x squared plus 2 plus the square root of 2x plus 1. And you really don't need to simplify it, I don't think. I don't think they make you simplify it. Your domain, you have to decide, is there anything that's going to make this 0? So you would subtract 2, and 5x squared equals negative 2, divide by 5. Is there any way you can put a positive or a negative in and square it and then get a negative? No. So this is not possible. Okay? Not possible. That means there are no values that are going to cause you problems here. So the domain of this function would have been negative infinity to positive infinity, right? The domain of this function, you had to take your 2x plus 1 and say that it has to be, everything under this root has to be positive or 0. It can be 0, unless it's in the denominator, right? But it's not. It's just in the numerator, so it can have a 0. So we have the equal to here. If I subtract 1 from both sides and then divide by 2 on both sides, I'll see that x has to be greater than or equal to negative 1/2. So your domain is going to be negative 1/2 to infinity. Well, when you add two functions and you combine those domains, your domain is going to be what they share. And the only thing that they share is this. So this is going to be the domain for your new function. And when you multiply, you've got your 1 over 5x squared plus 2 times your square root of 2x plus 1. You can see that that square root of 2x plus 1 is in the top, and your 5x squared plus 2 is in the bottom. So that's your new function. And again, there's nothing that will make this 0 in the denominator. Okay, there are no x values that give you 0. Okay, so you don't have to worry about that, but you still have to worry about having a 0 underneath the root. So your domain for this one is going to be -1/2 to infinity. Okay, you can have 0 in the numerator. If this 2x square root of 2x plus 1 would have been in the denominator, then actually, yeah, because it was times. It wasn't division. So anyway, that's your answer. All right, so this is the question that I made the video for, okay, because I think this is difficult. When you are trying to find the domain and range of a composition function, you should always, whatever the second one is, it gets listed first, okay, the domain range, and then after that, the f gets listed, okay, and then you're comparing these two, the range of G and the domain of F. What do they share? They share a 3 and they share a 4. So to find the domain of F composition G, okay, find its domain, you are going to follow both of these numbers back to see what they go to. So 5 is going to be in your domain, and 3 and 1 are going to be in your domain because you're following you're following those back. So your domain is going to be 1, 3, 5. And then for your range, for your F composition G of X, you're following these back here. So you've got 6, and that looks like it. So 1, 3, 5 for your domain and 6 for your range. Let's see if we're right. 1, 3, 5, and 6. Okay, but that's the technique. If you have to play this again to make it make sense to you, so you can work any of these on Aleks, you are finding which ones are in the middle that they share, and they only shared a 3 and a 4, and then you follow that 3 and 4 back, and whatever numbers you hit from here, that's your domain. Follow the 3 and 4 back this way. This is your range, okay? Question number 10, find two functions such that F composition G of X equals H of X. So I'm putting the G of X into the X in F of X. So I have to be careful. I could choose the 7x squared plus 1 as my G, and then my F would have been square root of X. Or I could have chosen just 7x squared, and then my F would have been the square root of X plus 1. Okay, those are the easiest two. Question 11, suppose that the functions h and g are defined as follows. Find h divided by g of -4. Okay, so we know that's h of -4 divided by g of -4. So my h of -4 is going to be -4 plus 3 times -4 minus 6. My g of -4 is going to be -4 plus 1. So I've got a -1 times a -10 over a -3. So 10 divided by -3 should have given you -10/3. Find all values that are not in the domain of h and g. Or I'm sorry, of h divided by g. Well, think about this. The domain of this one is -infinity to positive infinity. The domain of this one is -infinity to positive infinity. But when you take them and divide, now you've got x plus 3 times x minus 6 divided by x plus 1. You cannot have -1. So you're going to say x equals -1 is the only value that would not be in the domain, okay? And then question 12, suppose that the functions q and r are defined as follows. Find the following. Q composition r of 1. So you could do Q of R of 1 if you wanted to. And so I could find R of 1, okay? So my R of 1 is the square root of 1 plus 8, square root of 9, 3, and then find Q of 3. And Q of 3 would be 3 squared plus 7, 9 plus 7, 16. So this is R of Q of 1. So my Q of 1 is going to be 1 squared plus 7, 8. So I'm finding R of 8. My R of 8 would be the square root of 8 plus 8. The square root of 16, 4. Okay, so you got 16 for the first one, 4 for the second one. And then the last one here, write the expressions for each of these. So if I had G plus H, I have X, oops, accidentally put plus. I have X minus 4 is my G, plus 2x squared. I would simplify that to 2x squared plus x minus 4. Okay, and then G minus H. So I've got my G, which is x minus 4, minus, I'm going to put parentheses, my H. So now I've got negative 2x squared plus x minus 4. That's my G minus H. And then G times H of negative 2, I'm going to do G times H of x, which is going to be my x minus 4 times 2x squared. And I can even simplify that if I wanted to. I could say that's 2x cubed minus 8x squared, right, if I simplified it. And then I want to find G times H of negative 2. So that's 2 times negative 2 cubed minus 8 times negative 2 squared. So 2 times negative 8 minus 8 times 4, negative 16 minus 32, negative 48 for that last one. And let's go ahead and check our answers for those last couple. I got 16 and 4, and then I've got these 3 answers. I'm going to go all the way to the end. Oops, what happened to it? It went away. There's those answers and the negative 48. There's my 16 and my 4. And then there was my negative 10/3, and my negative 1 was the only one that was not in the domain. Okay, so I hope this helped. Thank you.